Now, to improve the performance of the baseline design further, an optimization methodology is applied, which starts with a sensitivity study on the design parameters. So, for the design parameters, 10 meridional geometry parameters are selected first, as described here and shown in this image. So, we have the impeller widths, the curvatures and axial length, and the radius of the crossover bend, and some other parameters that control the maximum casing size, the axial distance, and the return channel curvature. Next, we select 10 more design parameters, of which 4 blade loading parameters and stacking angle is used for the impeller. 2 loading parameters and 1 work parameter is used to create the 2D diffuser geometry, and the return channel geometry is controlled by 1 loading parameter and 1 incidence parameter. So in total, there are 20 design parameters selected for this sensitivity study. Now, the initial ranges of all these design parameters were based on the baseline design values plus minus variation as shown here. And then to measure the sensitivity, first a reference design was generated by setting the value of all the design parameters to 25% of the range. After this, 20 designs were generated by systematically increasing or perturbing the value of any one design variable by 50% of the range. Then CFD was run for these 21 designs at 90 and 105% flow rates to measure the efficiency variation from the reference design. Now 105% was chosen instead of the target 110% to guarantee CFD results near the high flow condition can be obtained for all the different designs. And in fact, this methodology produces sensitivity results that are naturally normalized with respect to the range of the input variables, and is also a good compromise between cost and accuracy of performing bidirectional perturbation of the baseline. And then the variations of the two efficiencies were combined into a single parameter by inverse distance weighing from the design point. And finally, the sensitivity information of each design parameter was calculated using this equation and plotted as shown here. And then based on this, the 10 most significant parameters were selected as the final design parameters for the optimization.